There is a quiet frequency that hums across the stars. 1,420 megahertz, the whisper of hydrogen itself. For decades, astronomers have listened to this cosmic note, believing that if any intelligence ever tried to speak to us, it would begin here. And now, something is speaking. The signal comes from an object called 3I Atlas, the third confirmed visitor from another star system. It repeats a simple but haunting pattern. 8, 13, 8, 5, 13, 8 numbers that trace the rhythm of the Fibonacci sequence, nature's own code of balance and design. Each pulse echoes through the void like a heartbeat of logic, a mathematical breath woven into the silence of space. No language, no voice, only the perfection of numbers, as if someone, somewhere, chose the purest way to say, "We are here." As the physicist Carl Sagan once said, "Somewhere, something incredible is waiting to be known." Tonight, we listen to that possibility. A message that may not be a message at all, but an invitation written in the language of the cosmos. It began quietly, as most revolutions in science do, not with a flash of light, but with a rhythm. On the night of October 21st, 2025, 3 observatories, separated by 15,000 kilometers, each gazing at different corners of the same infinite sky, recorded something that defied coincidence. A pulse, then another, perfectly timed, perfectly repeating. It was as if the universe had exhaled in unison, and a handful of patient listeners had caught the breath. The scientists who first saw the signal did not celebrate. They froze. Years of experience had taught them that the cosmos can play tricks, that nature's static can masquerade as meaning, so they checked their instruments, recalibrated their receivers, and waited. Yet the pulse returned, unwavering, deliberate. Its pattern was too clean, its timing too exact. A tremor of realization began to ripple through the quiet halls of those distant observatories. This was not noise. In astronomy, distance often protects objectivity. A single telescope can err, 3 in harmony rarely do. The synchronization between stations across continents eliminated the simplest explanations: local interference, faulty wiring, the faint hum of human technology bleeding into the spectrum. What remained was harder to dismiss. A source far beyond Earth, steady and precise, beating through the void at 1,420 megahertz. The frequency of hydrogen, the most fundamental note in the cosmic symphony. For decades, that frequency had carried a kind of sacred weight among astronomers. It was the frequency of possibility, the waterhole in the radio spectrum, quiet and clean, a place where life, if it wished to announce itself, might choose to speak. The first generation of SETI researchers had staked their dreams there. They had built dishes in deserts and valleys, waiting for the day something might whisper back. Most of them had retired or passed away, their hopes fading into the static. But on that October night, the silence broke. The team hesitated to release their findings. History had not been kind to premature announcements. Every scientist remembered the lesson of the "wow" signal of 1977, that haunting, unrepeatable burst from Sagittarius that had turned out to be nothing but a cosmic ghost, or the pulsars of 1967, which were once called LGM, Little Green Men, before they revealed themselves as neutron stars. The cosmos is full of wonders, but it also punishes the eager, so the first discoverers chose caution over fame. They cross-checked their data, then sent encrypted summaries to colleagues thousands of kilometers away, asking only, "Do you see it too?" They did. What followed was not a moment of triumph, but of silence, the kind of silence that comes when the human mind meets something vast enough to shatter its boundaries. Every pulse that repeated across their screens felt like a question whispered directly into consciousness. "Who are you listening to?" As one researcher later said in a closed session, "When you eliminate all possible errors, what remains, however improbable, must be considered." It was an echo of Arthur C. Clarke's quiet faith in the rational unknown. For the first time in years, the SETI network stirred awake. Observatories once mothballed were reopened. Antennas reoriented toward the coordinates of 3I Atlas, the third known interstellar object ever detected. There was something profoundly human in the way they approached it, cautious, trembling, hopeful. They were not chasing proof of aliens. They were chasing the possibility that the universe might not be indifferent. As physicist Freeman Dyson once said, "We do not look for signs of life because we expect success, but because it is part of being human to wonder." The data continued to flow, each observatory's timestamps aligned within milliseconds. The signals carried no modulation, no encoded message, only the elegant repetition of numbers that formed a Fibonacci-like rhythm: 8, 13, 8, 5, 13, 8, too structured to be random, too subtle to be a broadcast of intent. A code of order written in the mathematics of life itself. In the days that followed, the discoverers barely slept. They rotated shifts, checked for cosmic rays, recalculated Doppler drift, eliminated satellite reflection, cross-referenced orbital mechanics. Still, the signal held. One astronomer compared it to listening to a heart that doesn't belong to you but beats in perfect time with your own. When the first unofficial discussions began online, under private channels and encrypted correspondence, there was an undercurrent of awe rather than panic. The veterans knew better than to claim discovery, but the younger researchers, those who had grown up in the age of exoplanets and gravitational waves, felt something different. The pulse carried a rhythm that was not just data, but narrative. It suggested design, it suggested choice, and that terrified them. To detect a pattern is to confront intention. To confront intention is to confront another mind. The implications were overwhelming, not because of fear of invasion or science fiction fantasies, but because it would mean we were no longer the only storytellers in the dark. The lead researcher, in a private memo leaked months later, wrote simply, "The moment you see the pattern, you understand you are being watched by something that does not need eyes." Such words never made it to the press. Officially, the discovery was labeled pending verification. But within the quiet circles of astrophysics, everyone understood that something irreversible had happened. Humanity had glimpsed the possibility that the void might not be empty, that the universe, vast and cold and silent, might still hum with intention. As the pulse continued through the night sky, it connected 3 observatories and countless human hearts into a single shared rhythm of curiosity. No celebration, no fear, only the stillness of knowing that something greater was speaking, not in words, but in the universal grammar of mathematics. Perhaps it was natural, perhaps not, but in that moment, under the slow turning of the Earth, every scientist who saw the data felt the same quiet truth expressed long ago by Albert Einstein. The most incomprehensible thing about the universe is that it is comprehensible, and so they listened, breath held, instruments tuned, to a sound that might be both proof and poetry, a reminder that even across the unimaginable distances of space, there can still exist a pattern that recognizes itself. They had been listening for less than 2 nights when the first confirmation arrived. In Chile, under the clear and frozen skies of the Atacama Desert, another observatory tuned to the same frequency caught the same breath of the cosmos. The pulse that had appeared in 3 isolated observatories now repeated itself halfway across the world. The air was thinner there, the silence deeper, and when the data scrolled across the screen, the lead operator whispered a single word, almost afraid to disturb the moment. Asterisk. It's real. Asterisk. Back in the first control rooms, messages began to pour in from the southern hemisphere. Australia confirmed it first. Then South Africa. Each separated by thousands of miles, yet hearing the same voice of hydrogen, the same 1,420 MHz pulse, repeating with perfect symmetry. Within 48 hours, the signal had crossed the world. Every independent verification tightened the circle of certainty. What once could have been a trick of a single instrument had now become an undeniable fact of nature, or perhaps of something beyond it. The transition from doubt to astonishment was quiet. There were no headlines, no grand announcements, only a series of encrypted transmissions between teams that all said the same thing in different languages. Asterisk. We see it too. asterisk. And suddenly, what had been an isolated whisper became a chorus of confirmation echoing around the planet. The wave pattern was too clean. Its intervals never drifted. Its pulse, repeating every 142 seconds, stayed locked to the hydrogen line with impossible precision. Even as the Earth rotated and observatories passed from night to day, the signal remained stable, like a lighthouse beam sweeping evenly across the dark. It had none of the chaotic fingerprint of natural interference. The data did not scatter. It sang. In South Africa's Karoo Desert, the engineers of the Meerkat Array reviewed the waveforms again and again. One of them, a veteran of pulsar surveys, sat back in disbelief. "You can fake randomness," he said softly, "but you cannot fake intention." His colleagues didn't answer. They simply stared at the rhythm that pulsed across their monitors, steady as a metronome, ancient as the stars. The confirmation of a consistent source was the point at which skepticism began to dissolve, not because everyone suddenly believed it was artificial, but because it was too deliberate not to question everything they thought they knew. Natural phenomena can be powerful, chaotic, majestic, but rarely perfect. The perfection of this signal was what terrified them most. By the second night, coordination between observatories became a symphony of precision. Timestamps were cross-checked down to the millisecond. The same pattern appeared regardless of hemisphere, season, or atmospheric distortion. When data from all stations were overlaid, the waveforms aligned as if orchestrated by an unseen conductor. The scientists began to call it times the harmonic asterisk, though no one dared to say what they really meant. In the quiet corridors of the International Astronomical Union, discussions turned from curiosity to procedure. What if the signal was not random? What if it truly was a deliberate transmission? The question hung like gravity over every conversation. The SETI protocols written decades ago for such a discovery were suddenly taken out of archives and read aloud, as if invoking an ancient ritual. Each step required verification by multiple independent sources, and every source already confirmed the same truth. The pulses were identical. Their mathematical structure was consistent with the Fibonacci sequence that had first caught everyone's attention, and their energy distribution followed no known astrophysical pattern. No pulsar, no quasar, no solar flare behaved this way. The universe was speaking with order, not with noise. In Chile, a senior astrophysicist was recorded saying to his assistant, "If this is natural, then we are about to discover a new kind of nature." The quote would later circle among researchers like a quiet mantra. It captured the paradox perfectly. The data defied chaos. The universe, which had always whispered through randomness, was suddenly counting. By the end of the 48 hours, confirmation had turned into consensus. Across continents and time zones, astronomers faced the same realization. If multiple observatories, using different equipment, all detected the same pattern, then the source had to be real, external, and coherent. That left only two possibilities: either a natural process more precise than anything previously known, or an artificial signal built by intention. The distinction between those two possibilities is the threshold of human imagination. As Carl Sagan once wrote, "Extraordinary claims require extraordinary evidence." And here, extraordinary evidence was forming not in one place, but in many, connected by trust, discipline, and the shared humility of discovery. The data analysts ran new simulations, stripping the signal through layers of noise, filtering every possible Earth-based interference, satellites, radar, even reflections from the moon. Everything was eliminated. The pulse remained, a clean wave of logic, threading through the emptiness. On the second night, as dawn began to rise over the Australian outback, a group of young astronomers stepped outside their dome to watch the pale horizon. The desert was silent, the dishes still turning toward the invisible source. One of them murmured, "Do you think it knows we're listening?" No one answered. The question itself felt too heavy to bear. When the global confirmations were compiled, a single image summarized it all. 3 lines of data, 3 continents, 1 pulse. The scientists stared at it, as if it were a relic from the future. A few dared to imagine what it might mean. A message, a beacon, a mathematical handshake across the dark. But others were careful not to surrender to wonder too quickly. They knew the weight of false hope. They remembered how easily belief can outpace evidence. Yet, there was no denying the truth of what had been observed. The universe had given them symmetry, and in science, symmetry is the closest thing to intention. By the third day, rumors began to circulate in private academic forums. Words like times non-terrestrial origin times and times artificial periodicity times appeared in cautious sentences wrapped in disclaimers. But everyone reading them felt the same electricity. They had crossed a boundary from anomaly to signal, from question to recognition. No press releases were issued. Officially, it was just an unexplained narrowband emission. But in every observatory on Earth, behind closed doors and flickering monitors, the same unspoken thought lingered. This could be it. The hydrogen line had always been humanity's chosen listening post, the universal language of existence. Now, at last, someone or something might be speaking through it. The realization settled into the hearts of those who understood its weight. In a note written that night, one scientist quoted Werner Heisenberg, "What we observe is not nature itself, but nature exposed to our method of questioning." And perhaps, she thought, the universe was answering our question, not with words, but with a pulse. It was no longer about proof. It was about wonder, the kind that humbles you, the kind that makes you realize that knowledge and mystery can exist in the same breath. As the synchronized pulse continued to hum over the world, from Chile to Australia to South Africa, humanity stood together beneath the same sky, listening to the same sound, bound by the same quiet truth. We were not merely observers anymore. We were participants in a dialogue older than our species, one that had finally, mercifully, begun to speak back. The confirmations kept arriving until disbelief could no longer survive. Across the world, the data aligned into one steady rhythm, the same mathematical breath pulsing at 1,420 megahertz. It was no longer an anomaly. It was a voice, not in sound or language, but in the purity of frequency. And to those who listened, that number carried a meaning that went far beyond mathematics. It was not just a coordinate in the spectrum. It was the heartbeat of hydrogen, the simplest and most ancient element in existence, the one that built every star and every cell, including us. In Chile, an astronomer stared at the spectral graph glowing on his monitor and whispered, "Of all the places to speak from, they chose the one we have been waiting for." He was not exaggerating. For decades, astronomers have regarded 1,420 megahertz as sacred ground, the one universal meeting point where science and hope intertwine. This frequency corresponds to the radio emission of neutral hydrogen, the most abundant element in the universe. Every hydrogen atom, when its proton and electron flip alignment, releases a photon that vibrates at that exact frequency. It is the signature of existence itself, the quiet hum of creation spread across the cosmos. In 1959, two physicists, Giuseppe Cocconi and Philip Morrison, wrote a paper in Nature Times that would forever change how humanity listened to the stars. They proposed that if any civilization wanted to send a signal across interstellar space, it would make sense to use the hydrogen line. Their reasoning was simple, yet profound. Hydrogen is everywhere. Any intelligent being capable of building a radio telescope would know it. Morrison and Cocconi called it a universal channel of communication. That idea became the cornerstone of SETI, the search for extraterrestrial intelligence. From that moment on, 1,420 megahertz was no longer just a number. It was a promise. Decades later, astronomer Frank Drake expanded on that vision. In his legendary equation estimating the number of communicative civilizations in our galaxy, he placed the hydrogen frequency at the center of his first experimental search, Project Ozma. For the first time in history, radio dishes in Green Bank, West Virginia, were turned not towards stars for study, but for conversation. Drake once said, "If we are to listen, we should listen where nature itself is quiet." That quiet place became known as Time's the waterhole asterisk, a metaphor drawn from the African savanna, a calm refuge where all species gather to drink. Between the noisy emissions of hydrogen and hydroxyl lies a natural gap in the cosmic radio spectrum, a tranquil band of silence. If the universe had a place to meet, it would be there. That is why, when the pulse from 3I Atlas appeared precisely on that frequency, astronomers around the world felt something between awe and disbelief. It was as if someone had not only spoken, but chosen the one place where we had long been waiting to listen. There is symbolism in that precision, the same way a traveler, leaving a message on a familiar path, ensures it will be found. The hydrogen line is the cosmic trailhead of intelligence. Whoever, or whatever, sent a signal here knew we would understand. The scientists who analyzed the data described the frequency with reverence. It was stable to within a fraction of a hertz, unwavering through hours of observation. That kind of stability is unnatural for most astrophysical sources. Quasars drift, pulsars flicker, interstellar gas scatters and broadens emissions. But this one remained fixed, like a laser beam anchored to the laws of mathematics. Its purity seemed intentional. Every civilization, human or otherwise, must eventually confront the same truth. The universe speaks most clearly through simplicity. Hydrogen is the simplest atom, the first building block after the Big Bang. It binds stars, fuels fusion, and fills the void. To speak in hydrogen is to speak in the oldest tongue there is. When SETI scientists talk about 1,420 megahertz, they often describe it as the language of nature. Carl Sagan once said, "If we ever do receive a message from the stars, it will not be in words, but in patterns of nature itself." The idea was that communication across light years must rely on constants, on truths that remain the same everywhere: the speed of light, the frequency of hydrogen, the rhythm of mathematics. The universe may not share our languages, but it shares our physics. As the data continued to arrive, the implications began to unfold in whispers among the teams. The choice of this frequency could not be random. It was too symbolic, too deliberate. If the source had been natural, it would have been a coincidence of cosmic proportions, a signal from the element that defines existence. At the frequency, every intelligent being would know. But if it was deliberate, it meant something astonishing. Whoever sent it wanted to be found. A senior astrophysicist at the European Southern Observatory wrote in her logbook that week, "If the universe has a common ground, 1,420 megahertz is its native soil." Her words resonated across private channels among researchers, a poetic confession that science sometimes stumbles into philosophy. To detect a signal there was to confront the possibility that intelligence somewhere, somehow, had looked at the same sky, recognized the same frequency, and chosen to reach across the void. The beauty of 1,420 megahertz lies in its inevitability. It is not ours, it belongs to the universe. It exists with or without us, and yet, we have built meaning into it. The way early humans built meaning into fire, we have decided that this is the place where curiosity and hope meet, the line in the spectrum where silence could turn into voice. When the first cross-checks were done, and the signal's alignment with the hydrogen line was confirmed beyond doubt, the realization spread quietly through the scientific community. It was not just a detection, it was an echo of prophecy. Cocconi and Morrison had predicted this exact scenario 66 years earlier, and now the universe seemed to be following their script. If they exist, they will use this channel, they had written. And now, something was. In the days that followed, journalists would speculate about aliens, skeptics would demand more data, and institutions would issue cautious statements about unidentified, narrowband sources. But for those who had been listening their whole lives, the moment carried a deeper, more intimate meaning. It felt less like discovery and more like recognition. The hydrogen line was never meant to belong to one world. It was meant to unite many. Whether the source of the signal was natural or artificial, random or deliberate, it reminded humanity of something profound, that we are made of the same substance as the stars, and that the universe may not be silent, only patient. Physicist Erwin Schrödinger once said, "The task is not so much to see what no one else has seen, but to think what no one else has thought about that which everyone sees." The hydrogen line had always been there, shining through the cosmic noise. We had simply waited long enough and believed deeply enough to recognize its meaning. And so, in the quiet hum of 1,420 megahertz, the world heard not just a signal, but a mirror. It reflected our longing, our curiosity, and the unspoken hope that somewhere, in the vast stillness between the stars, someone was listening too. For a moment, the world listened in silence to the hum of 1,420 megahertz, that sacred tone of hydrogen. It was pure, calm, and deeply familiar, as if the universe itself had drawn a breath. Yet within that steady rhythm, hidden beneath the simplicity of the frequency, something else began to reveal itself. A pattern. Numbers arranged not by chance, but with purpose. The hydrogen line had carried a whisper, but the whisper contained a code. When the data was decoded, 6 numbers appeared again and again. 8, 13, 8, 5, 13, 8. The pattern was too deliberate, too elegant to dismiss. The numbers belonged to the Fibonacci sequence, that infinite progression found in everything from the spirals of galaxies to the arrangement of leaves on a stem. The scientists who stared at the sequence that night realized that this was not language, it was logic. The Fibonacci sequence is more than a mathematical curiosity. It is a symbol of order embedded in the fabric of creation. Starting with 1 and 1, each number becomes the sum of the 2 before it, producing a ratio that approaches the golden mean, 1.618, a proportion that defines beauty, symmetry, and life itself. To see it emerge in a signal from beyond our solar system was to glimpse the fingerprints of reason. In the quiet of the observatories, someone whispered, "This is not random." The words hung in the air like a confession. Every civilization that reaches intelligence must, at some point, discover the same truths of mathematics. Numbers are the only language that does not belong to one world or one species. They are universal. If an extraterrestrial intelligence wished to prove its existence without the ambiguity of words or symbols, numbers would be the bridge. Carl Sagan once said, "Mathematics is the only truly universal language." That idea now echoed through every data lab on Earth. The sequence was not a message in the sense of vocabulary or syntax. It was a demonstration of intellect, a handshake offered through the cold dark of space. To send Fibonacci was to say, "We understand the laws of growth. We understand symmetry. We understand you." The deeper the scientists examined the pattern, the more they realized its precision. The repetition of 3 consecutive Fibonacci numbers was not random arrangement. It was recursive, looping, almost rhythmic. In signal theory, such repetition implies intention. Natural phenomena can repeat, but they rarely obey abstract mathematical rules with such accuracy. The signal was not shouting, but whispering with purpose. In the dim light of the data room, one astrophysicist murmured to herself, "It is not speaking in sound, it is speaking in structure." That insight transformed the investigation. The pulse, at 1,420 megahertz, was no longer just a frequency. It was a carrier, a vessel for meaning encoded in mathematics. The universe, or something within it, had chosen the most objective form of communication possible. The Fibonacci sequence is everywhere in nature, but its recurrence here was almost poetic. It forms the spirals of shells, the growth of pine cones, the distribution of petals, even the curves of galaxies. Leonardo da Vinci used it unconsciously in his art. Kepler saw it in planetary motion. To find it pulsing from the depths of interstellar space was to find a reflection of ourselves staring back. The physicists debated whether the sequence was intentional or coincidental. Some argued that natural harmonics could generate such patterns under rare conditions. Others insisted that the probability of random emission producing that exact progression was infinitesimal. Eventually, they reached an uncomfortable agreement. If it was not natural, it was intelligent. And if it was intelligent, it was deliberate. There was something humbling in that realization. For centuries, humans have sought to define intelligence by the ability to use language or technology. But what if true intelligence is the ability to recognize patterns in chaos, to send meaning through the order of numbers? If another civilization had done that, it meant they understood not only logic but empathy, the capacity to reach out across impossible distances and choose a medium we could understand. A mathematician in Geneva wrote in her log, "They chose Fibonacci because it belongs to both of us." The statement was simple, but it captured the essence of the discovery. Mathematics transcends biology. A carbon-based life form and a silicon-based one would both discover prime numbers, geometry, and ratios of harmony. In that sense, the signal was not alien. It was familiar, even intimate. There were no words attached, no images, no codebook, only the sequence. And that may have been enough. The power of Fibonacci lies in its simplicity, its self-reference, its inevitability. It is the mathematics of emergence, of order arising from simplicity. To send it is to declare, "We exist within the same laws that you do." Physicist Richard Feynman once remarked, "If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration." The signal at 1,420 MHz seemed to obey that very principle. It did not speak in sound, but in vibration. Not in emotion, but in rhythm. Its beauty was not in its message, but in its precision. As more observatories joined the analysis, a consensus began to form. The repetition of Fibonacci numbers might not be a message in itself. It could be an opening key, a preface, a signal of readiness. In information theory, a repeated pattern often acts as a synchronizing code, a way of aligning sender and receiver before the true message begins. Perhaps this was not the message, but the invitation to decode one. In that possibility lay both wonder and fear. If the Fibonacci pulse was a prelude, then what would come next? Would there be modulation, complexity, an evolution of the sequence into language? Or was the message already complete, existing not in transmission but in recognition? Late that night, a radio astronomer at the South African Array recorded a private note. "For the first time, I feel as if we have been seen." It was not the data that moved him, but the symmetry, the way something out there had mirrored our own understanding of beauty and logic. Mathematics is not owned by humanity. It is discovered, like fire. It was always there, waiting to be recognized. The Fibonacci sequence is perhaps the most human expression of that discovery, a pattern that feels alive, growing endlessly outward, reaching for the infinite. Stephen Hawking once said, "The universe is under no obligation to make sense to you." And yet, here was a pattern that did make sense, perfectly so. It spoke in the same ratios that shaped the shells of snails and the arms of galaxies. It was as if the cosmos had chosen to speak in the only language that required no translation. So when the pulse continued, looping endlessly through the silence of interstellar space, humanity listened with a new kind of awe. The message might never spell out words, but its meaning was unmistakable. It was a mathematical signature, a proof of thought, and in its simplicity, it reminded us that intelligence, wherever it arises, will always recognize itself in the order of the universe. The Fibonacci pulse continued without pause, repeating itself across days and hemispheres. By now, it had become impossible to ignore. Each confirmation, each verification, deepened the same haunting question. What could produce such precision, such order, such mathematical intent? Nature had always been capable of wonder, but rarely of symmetry this pure. The world's leading observatories agreed on one thing: the signal was real. Yet what it meant remained beyond reach. Within the first week of analysis, three main hypotheses began to crystallize. They were not conclusions, only possibilities, fragile frameworks suspended over an ocean of uncertainty. The first was the most conservative and, perhaps, the most human. The signal might still be natural. The universe is vast, and our understanding of it is incomplete. There are forces and phenomena that remain unseen, processes not yet modeled, frequencies that hum in the dark beyond our comprehension. As one researcher reminded the team, absence of explanation is not proof of design. It was a call for restraint, a reminder that wonder must be disciplined by doubt. Yet even those who clung to the natural hypothesis could not ignore how unusual the data appeared. The frequency was locked exactly to 1,420 megahertz, stable to a precision of billionths. The sequence repeated in perfect intervals, immune to drift or interference. Natural systems rarely maintain such consistency. Quasars, pulsars, plasma jets all fluctuate with time and turbulence. This pulse did not. It was steady, deliberate, and unchanging. If it was natural, it would require the discovery of a phenomenon unlike anything known to astrophysics. The second hypothesis was more daring. The signal could be deliberate. Perhaps it was the result of a transmission sent intentionally, a beacon designed to announce presence rather than convey language. Throughout SETI's history, scientists had debated this possibility. Would a civilization broadcast across the stars, or would it hide in silence, wary of predators in the dark? In this case, the choice of 1,420 megahertz and the Fibonacci sequence seemed too meaningful to dismiss as coincidence. It was as though the sender had chosen not only where to speak, but how through the one frequency and one pattern guaranteed to be recognized by any intelligent species. In Chile, a scientist from the European Southern Observatory noted in her journal, "It is not what they are saying that matters. It is that they knew we would be listening." That thought unsettled even the most rational minds. If someone was transmitting, it meant intention. And intention implied awareness. Were we being greeted or observed? Was this a message meant for anyone, or was it specifically directed at us? The debate deepened. Some argued that no advanced civilization would use such an energy-inefficient method to communicate. The vastness of interstellar space makes direct transmission costly and slow. Others countered that the simplicity of the message was the point, not conversation, but contact. A single mathematical pulse could serve as a universal handshake, a declaration of existence. The third hypothesis was the most unsettling. It proposed that the signal did not come from a transmitter at all, but from the object itself. 3. Atlas might not be a comet or a fragment of ice and rock. It might be the source. The idea sounded absurd at first, yet the evidence for 3I Atlas already defied known cometary behavior. Its light curve fluctuated unnaturally, its composition lacked the expected water signature, and its trajectory was precise beyond prediction. Could it be an artifact, a probe, or a relic from another civilization, crossing our system under the camouflage of natural motion? In South Africa, an engineer working on signal modeling remarked, "If the object is broadcasting, then it's not just visiting, it's reporting." The statement chilled the room. For decades, humans had wondered whether other civilizations were listening. Few had asked what would happen if they were watching instead. The scientific community struggled with the implications. They built models to test every alternative: solar interference, magnetospheric reflection, Doppler distortion. None could reproduce the Fibonacci pattern or its persistence. The object moved predictably, and yet its pulse remained synchronized, independent of distance or orientation. It was as if the signal existed outside of physical mechanics, guided by something unseen. A theoretical physicist at Caltech compared the phenomenon to a controlled transmission. If you were to design a probe to announce its presence without revealing its origin, he wrote, this is how you would do it. Short, mathematical, unambiguous. The idea circulated quietly through encrypted scientific networks, but was never mentioned in official reports. To label something artificial without absolute proof would be reckless. Still, the possibility lingered, unspoken, but undeniable. Each hypothesis carried its own kind of fear. The natural explanation comforted the rational mind, but demanded new physics. The deliberate transmission thrilled the imagination, but raised the specter of being observed. The probe theory was the most radical, and therefore the most dangerous. If true, it would mean that for the first time in history, humanity was not merely looking into the cosmos, but being looked back at. Freeman Dyson once wrote, "The universe is not obliged to be kind to our curiosity." That truth weighed heavily on the scientists. They were explorers of data, not dreamers of mythology. Yet the numbers forced them to confront the possibility that the boundary between science and wonder might not be as wide as they once believed. By the end of that week, committees met behind closed doors. The language of the discussions was careful, measured, and coded. Words like anomaly, correlation, and verification replaced phrases like message and intelligence. Publicly, they maintained caution. Privately, some began to prepare for a revelation they could barely articulate. The night sky above Earth remained unchanged, the same constellations, the same quiet shimmer of starlight. Yet something had shifted. The hydrogen frequency that once represented the calm of the universe now carried the weight of attention. Humanity, for the first time, was not just listening to the cosmos. It was wondering if the cosmos was listening back. If 3I Atlas was a comet, it was the most mysterious ever observed. If it was something more, then the story of human discovery was about to enter a chapter no one had dared to write. And somewhere, beyond the veil of light, the Fibonacci pulse continued to echo, as if waiting for us to decide what we believed, a trick of nature, a message of intent, or the heartbeat of an intelligence older than our own. The debate over the nature of the signal deepened until it could no longer be separated from the mystery of the object itself. Theories multiplied, each more daring than the last, yet all of them circled the same unavoidable truth. Everything strange about the transmission pointed back to 3I Atlas. If the pulse was real, if the Fibonacci pattern was deliberate, then the source could not be ordinary. As one astrophysicist wrote in her notes, "To understand the message, we must first understand the messenger." When astronomers turned their telescopes back toward the faint speck crossing the outer solar system, what they saw challenged every known model of cometary behavior. 3I Atlas was not like Oumuamua, the first interstellar visitor observed in 2017, nor like 2I Borisov, the second, seen in 2019. Those two had been enigmas in their own right, one tumbling strangely, the other trailing a familiar tale of gas and dust. But 3I Atlas was something else entirely, both familiar and alien in its motion, as though it obeyed laws we could recognize but not predict. Its size was the first anomaly. Initial measurements placed it at several times the length of Oumuamua, perhaps 100 meters or more, with a reflective surface that changed brightness in ways no natural object should. The fluctuations in light did not match the slow, irregular spinning of a comet. Instead, they appeared rhythmic, almost controlled, as if the object adjusted its orientation deliberately. The data forced astronomers to ask an uncomfortable question. Was this an object reacting to sunlight, or something reacting to observation itself? The speed was the second mystery. 3I Atlas was moving far faster than either of its predecessors, entering the solar system at a velocity that defied gravitational expectations. Even accounting for solar influence, its trajectory seemed too precise, its deceleration too uniform. Natural bodies, especially interstellar ones, tend to follow chaotic paths shaped by chance encounters with stellar gravity. 3I Atlas moved differently, smooth, stable, purposeful. In Hawaii, where the Pan-STARRS telescope first detected the object, analysts compared its orbital data to those of thousands of known comets. The differences were striking. It did not exhibit the traditional signatures of outgassing that typically propel and alter a comet's motion. Instead, its acceleration remained constant and uncorrelated to solar heating. When plotted against solar distance, the curve looked artificial. It behaves as if something is compensating for the pull of the sun, one researcher noted quietly during a late-night review session. The light itself offered further puzzles. Observers noted rapid variations in brightness that did not align with rotational periods. The reflections oscillated in patterns too symmetrical to be random, hinting at structured surfaces, flat planes, perhaps metallic facets, unlike the rough ice and dust expected of a natural body. In several frames captured by the Very Large Telescope, 3I Atlas shimmered with polarized light far stronger than any comet ever recorded. Polarization of that magnitude usually requires manufactured materials. The data were difficult to accept, even for those who had already abandoned conventional explanations. Physicist Avi Loeb, who had famously argued that Oumuamua might be artificial, was quick to comment when preliminary reports were leaked. "If it looks like technology and behaves like technology," he said, "then it might be technology." Many scientists dismissed the remark as premature, yet the resemblance between Loeb's earlier claims and the new evidence was impossible to ignore. 3I Atlas displayed every trait that had once made Oumuamua controversial, amplified to a scale no one could explain away. As global networks analyzed the object, patterns emerged that defied coincidence. The periodicity of the radio signal matched the fluctuations in brightness, as though both originated from the same underlying mechanism. Every 8 minutes, a faint shift in reflected light coincided with a corresponding modulation in the radio pulse. The synchrony was too precise to be chance. Theorists began to suggest that 3I Atlas might be rotating, not randomly, but with intent, as if maintaining a stable line of communication. If true, that would mean the object was not just an emitter, but a designed instrument. The very thought was almost heretical. For decades, scientists had searched the skies for signs of life, but few had truly expected to find evidence of craft. The idea that an interstellar visitor could be a probe, silently transmitting mathematical proof of intelligence, felt closer to mythology than astronomy. And yet, the numbers would not relent. Even the comet's spectral composition defied explanation. Infrared data from the James Webb Space Telescope revealed chemical ratios no known natural body had ever exhibited. Carbon monoxide appeared in abundance, but water was nearly absent. The presence of nickel without corresponding iron suggested a refined material, one that does not occur in typical cometary formation. A metallurgical engineer at MIT commented that the data resembled the byproducts of industrial processes rather than geological ones. The conclusion was not stated openly, but it hung unspoken in every discussion. This object did not behave like a rock. It behaved like a design. Still, skepticism persisted. Scientists are trained to distrust extraordinary conclusions. Could there be unknown physical processes at play, interactions of magnetic fields, plasma flows, or dust scattering that mimic precision? Every model built to explain the data failed to reproduce all variables at once. Something always remained unaccounted for, as though a hidden factor guided the motion. Freeman Dyson once reflected, "The universe is big enough to contain surprises we have not yet imagined." His words were quoted repeatedly in the debates surrounding 3I Atlas. Perhaps this was one of those surprises, a natural object masquerading as the impossible. Or perhaps it truly was something more, a deliberate artifact that had crossed light years not by accident but by design. The public would later come to know 3I Atlas as the most enigmatic traveler ever observed. Its light curve became the subject of documentaries, its orbital maps of endless speculation. Yet for those who studied it firsthand, the experience was quieter, almost spiritual. Watching that faint point of light drift through the telescope's field was like staring at a question too large to answer. It did not explode, it did not vanish, it simply moved perfectly, impossibly, beautifully. By early November, consensus had vanished. Some claimed it was an unusually dense fragment of interstellar ice. Others whispered that it was a probe operating in stealth. The only certainty was its difference. It was larger, faster, and stranger than anything humanity had ever recorded. "We are witnesses to an object that defies every box we have built to hold it," said one scientist during a conference call. "And when nature defies our boxes, we must decide whether to build new ones or accept that we have just seen the work of mind." The world did not yet know how to interpret 3i Atlas, but as its bright path curved toward the sun, one thing became undeniable. This was no ordinary visitor. Whether comet, craft, or something in between, it had already rewritten what humanity thought possible, and behind its silent motion lingered the same quiet rhythm that had started it all, the Fibonacci pulse, echoing across hydrogen, as if to remind us that logic and wonder may not be so different after all. As the data from ground-based telescopes deepened the mystery surrounding 3i Atlas, a more powerful eye turned its gaze toward the object. The James Webb Space Telescope, orbiting silently far beyond the distortion of Earth's atmosphere, began its spectral analysis. The goal was simple: to determine what this strange visitor was made of. Yet the results that arrived days later only darkened the mystery. Every chemical signature, every ratio, every reflection of light seemed to defy the familiar grammar of the cosmos. What James Webb found was not the chemistry of a comet. It was the chemistry of something that should not exist. Compared to the thousands of comets studied over the past century, 3i Atlas broke every rule. Ordinary comets are built of water, ice, silicate dust, and carbon compounds frozen together since the birth of their parent stars. When they approach the sun, the heat releases plumes of vapor that shape their tails, rich in water, simple organics, and the faint scent of primordial chemistry. But the spectrum of 3i Atlas told another story. The dominant signature was carbon dioxide, not water. The ratio was reversed, as if the recipe of creation had been rewritten. Instead of the familiar fingerprints of frozen oceans, Webb detected a world of dryness, an object that had formed where water could not survive. At first, scientists wondered whether the readings might have been corrupted by instrument noise or cosmic dust scattering. They recalibrated the data. The result was the same: carbon dioxide dominated by an overwhelming margin. The usual signatures of H2O were nearly absent. "Nature does not invert its own laws without reason," one chemist said quietly during the review meeting. The absence of water was not just unusual, it was unnatural. Then came the more shocking discovery. The spectral lines revealed traces of nickel, a heavy element that should, by all chemical logic, be paired with iron. In every natural process known to astrophysics, nickel and iron are born together, forged in the dying breaths of massive stars and scattered through supernova explosions. Their atomic kinship is inseparable. Where one is found, the other must be present. But 3i Atlas carried nickel alone, bright and clear, with no corresponding signal of iron. The observation was, as one researcher put it, chemically impossible. If the data were correct, then something had refined this material, separating one element from another with surgical precision. Such a separation does not occur in nature. It requires heat, control, and purpose. It requires technology. The possibility hovered in the air like static. When the team ran deeper analysis, a new compound emerged from the spectral patterns: nickel tetracarbonyl. On Earth, it is an industrial compound, formed only in controlled environments where carbon monoxide reacts with pure nickel. It is toxic, volatile, and used primarily in metal purification, a hallmark of metallurgy, not geology. The laboratory that confirmed the signal hesitated to publish. To detect nickel tetracarbonyl in a celestial object was to imply a process that mimicked or originated from intelligent manufacture. In the corridors of the European Space Agency, the conversation shifted from wonder to disbelief. Could an interstellar body carry the chemical memory of technology? One scientist compared the finding to discovering a piece of machinery floating in deep space. "If we are correct," she said, "then this is not a comet, it is a relic." The suggestion drew both fascination and resistance. Some argued that unknown chemical processes in the cold interstellar medium could produce such compounds naturally. Perhaps under extreme conditions, carbon monoxide and metal vapor could form temporary bonds that mimic industrial chemistry. Others countered that the precision and concentration seen in the spectra could not arise from random chance. The formation of nickel tetracarbonyl requires specific temperatures and pressures the kind one would find inside a refinery, not a nebula. Freeman Dyson once said, "When science discovers something that does not fit, it is often the universe inviting us to think bigger." That sentiment guided the few who dared to take the results at face value. Maybe the object was artificial, or maybe it was ancient debris from a civilization long extinct. If matter can preserve intention, perhaps 3I Atlas was a fossil of thought, a chemical echo of intelligence lost to time. Others remained cautious. The word artificial carries weight that science cannot easily support. To declare it would be to rewrite the story of astronomy itself. Yet the question lingered in every report, in every whispered conversation between research teams across continents. Who made this? The data continued to flow from James Webb's instruments. As the object neared its closest approach to the sun, the readings became clearer, sharper, more defiant. The nickel signature strengthened, the water remained missing, and the peculiar alignment of molecular bands confirmed the presence of carbonyl compounds. These were not coincidences. They were fingerprints. In a small meeting at NASA's Goddard Space Flight Center, one materials scientist stood and wrote 2 words on the whiteboard: industrial residue. The room went silent. She explained that the spectral lines matched what one would expect from processed metal, exposed to high temperatures and cooled in vacuum, the exact environment of space manufacturing. If a civilization had ever built orbital machines, she said, this is what their remains would look like after millennia adrift. Her proposal was not officially recorded, but it spread through the scientific community like an ember. The hypothesis did not need to claim that 3I Atlas was a functioning craft. It only had to suggest that its matter once belonged to a machine. That possibility alone was enough to reshape the meaning of discovery. Carl Sagan's words resurfaced in quiet discussions. Extraordinary claims require extraordinary evidence. The evidence was accumulating, yet extraordinary did not begin to describe what it implied. To find a compound born of metallurgy floating among the stars was to encounter purpose in the raw chemistry of the cosmos. The paradox grew more intense as more observatories confirmed the data. Independent analyses from Chile and Japan reproduced the same chemical pattern. No one could explain how a natural body could carry such an inverted ratio of water to carbon dioxide or contain metallic compounds so precisely structured. If it was natural, it was nature behaving as an engineer. If it was artificial, then humanity had just glimpsed its first fragment of alien craftsmanship. The notion that chemistry could bear witness to intelligence was both thrilling and terrifying. It stripped away the comfort of distance. Radio signals can be dismissed as coincidence or noise, but matter cannot lie. Matter remembers how it was made. And 3I Atlas, in its spectral silence, seemed to be remembering something that no comet ever should. Richard Feynman once said, "Nature uses only the longest threads to weave her patterns. So each small piece of her fabric reveals the organization of the entire tapestry." If that is true, then perhaps the chemistry of 3I Atlas is one of those threads, a fragment of the universe's greater design, or a relic of minds who once sought to master it. The team continued their work in quiet awe. They knew that every new discovery would demand both humility and imagination. The universe, vast and indifferent, had offered them a clue that felt almost personal. Somewhere within the shimmering dust of that interstellar traveler was a question, delicate yet impossible to ignore. Not, what is it, but who made it? The strange chemistry of 3I Atlas had already unsettled the scientific world, but the story did not end with its molecular makeup. The deeper astronomers looked, the more the universe seemed to break its own rules. Just as the team was beginning to comprehend the metallic signatures and the absence of water, a new mystery unfolded before their eyes. This time, it was not in the numbers or in the spectrograms. It was visible, undeniable, painted across the black canvas of space for all to see. When the first high-resolution images from ground telescopes were released, they showed something that should have been impossible. The comet's tail, that familiar plume of dust and gas every schoolchild recognizes, was pointing the wrong way. Instead of streaming outward, away from the sun, driven by solar radiation pressure as physics dictates, the tail of 3I Atlas was facing directly toward it. For a brief moment, the scientific community hesitated. Surely it was an illusion, a trick of light, a misalignment of perspective. But the data kept arriving, consistent and merciless. The anti-tail was real. Astronomers had seen optical illusions of this kind before, where the geometry of a comet's orbit creates the appearance of a reversed tail. Yet, this was not that. Multiple observatories across 3 continents, equipped with instruments designed to measure polarization and density, confirmed that the stream was physical, not visual. It was a concentrated jet of material, stable and narrow, maintaining shape against all known forces. Instead of being scattered by the solar wind, it moved as if powered from within, a deliberate thrust of matter aimed toward the star that every natural comet flees. At the European Southern Observatory, the control room fell silent as the data unfolded. One astrophysicist broke the stillness with a whisper. "It's not following the sun's command." That sentence captured the mood perfectly. The universe, for all its chaos, obeys laws. Gravity, radiation, and thermodynamics are constant. Yet here was an object behaving as if it answered to a different order. The anti-tail remained visible for weeks, unmoved by heat or pressure. It glowed with a spectral intensity, suggesting that the particles within it were metallic, possibly nickel compounds, the same strange material identified earlier by James Webb. If true, it meant that the object was expelling processed matter, not sublimating ice. The phenomenon resembled a jet rather than an exhalation, precise and directional. Natural comets shed their material in chaotic plumes, diffuse and shimmering. This was neither diffuse nor chaotic. It was focused. As the images multiplied, the comparisons grew bolder. Some scientists described the formation as a kind of propulsion. Others argued that it might be magnetic in nature, perhaps driven by an unknown interaction between the object's composition and the solar field. But none could explain why it began so suddenly, or why it ended in perfect synchrony with the start of the radio signal. That coincidence haunted everyone who studied it. The day the jet subsided was the day the Fibonacci pulse was first detected. The timing was exact to within minutes. In science, correlation does not prove causation, but it whispers to those who listen. The universe is full of coincidences, yet this one was too sharp, too meaningful. A mechanism turned off, a signal began, as if an action had been completed and a message sent. Richard Feynman once said, "Nature uses only the longest threads to weave her patterns." Perhaps the anti-tail was one of those threads, connecting physics to intention. It forced scientists to think in ways that blurred the line between engineering and astronomy. Could a comet generate thrust to alter its own trajectory? Could it control the release of matter with such precision? Could it, in some incomprehensible way, be performing a maneuver? Theoretical models struggled to keep up. The solar radiation pressure acting on the object should have stripped away any fine structure, yet the tail's alignment remained perfect. It did not bend or dissipate. The density profile measured by instruments in Chile suggested that the particles were moving at uniform velocity, as though emitted through a nozzle rather than dispersed by heat. For a moment, it seemed the object was not reacting to the sun but interacting with it. A physicist from Cambridge proposed an unorthodox idea. Perhaps the anti-tail was not matter at all, but energy, a beam of charged particles directed toward the star, using its gravitational field as part of a controlled trajectory. His paper was rejected for speculation, but the concept lingered in private discussions. If that were true, then 3I Atlas was not a comet. It was a craft. Skeptics urged caution. Nature, they argued, has produced stranger phenomena before. Plasma discharges, dust alignment, magnetic reconnection, all can create illusions of design. But the longer the anti-tail persisted, the harder it became to maintain skepticism. The formation was too stable, too symmetrical, too exact. Even the direction of its emission followed a rhythm that mirrored the periodicity of the radio pulse. In the vast language of physics, rhythm means control. Carl Sagan once wrote, "Somewhere, something incredible is waiting to be known." For many, this was that moment. The anti-tail, glowing softly against the solar light, became a symbol of the thin line between knowledge and belief. If it was natural, it would require new physics. If it was artificial, it would redefine our place in the cosmos. Either way, the discovery was extraordinary. The object's brightness began to fluctuate as the jet diminished. Without the anti-tail, it looked like any other faint speck of light among the stars. Yet those who had watched it understood that something profound had occurred. The universe had revealed a behavior that seemed to bridge the gap between matter and will. Freeman Dyson once said, "The universe is full of magical things patiently waiting for our wits to grow sharper." Perhaps the anti-tail was one of those magical things, a phenomenon that forced the human mind to stretch its imagination toward realms it was never meant to reach. As 3I Atlas continued its journey inward, the radio signal at 1,420 MHz began to stabilize into a repeating sequence. The anti-tail was gone, but its memory lingered, as if it had served its purpose. Some theorists quietly suggested that the jet had been a transmission method, that it might have released charged particles tuned to carry the radio emission through solar interference. Others dismissed the idea as poetic nonsense. Yet poetry has always walked hand in hand with science, and in this case, the line between them had never felt thinner. In the end, the mystery of the anti-tail became one more piece of the puzzle, a phenomenon that refused to fit within any known model. It was a visual paradox matter, flowing toward the very force that should have repelled it. A comet defying the sun, a tail rebelling against gravity, a law of motion rewritten before our eyes. Whether it was a natural anomaly or a controlled act, no one could say. But every astronomer who saw those images shared the same quiet realization. They were watching something deliberate, and as the last traces of the anti-tail faded into the solar glare, the signal from 3I Atlas began to sing across the void a Fibonacci pulse on the hydrogen line, as if the universe itself had inhaled and now, at last, was ready to speak. The day the anti-tail of 3I Atlas vanished, the cosmos seemed to fall silent for a breath. The strange jet that had defied physics faded into the solar glare, leaving behind only the faint shimmer of an ordinary comet. But just as the observers began to wonder if the mystery had ended, the radio receivers came alive. Across continents, in the quiet halls of observatories, on mountaintops and deserts, instruments began to hum with the same rhythm. It was a frequency so precise, so perfect, that every scientist who saw the number on their monitor felt the same chill. The signal was locked exactly at 1,420.4058 MHz, the absolute center of the hydrogen line. To the untrained ear, it was nothing more than a whisper of static. To those who understood, it was the most meaningful silence in the universe. Hydrogen is the most common element in existence, the foundation of stars, gas clouds, and life itself. When its single electron flips its magnetic orientation, it releases a photon at that exact frequency, 1,420.4058 MHz. Every radio astronomer knows this number by heart. It is the heartbeat of the cosmos, the universal constant that binds the visible and the invisible. For decades, this frequency had been sacred to the search for extraterrestrial intelligence. It is the quietest region of the radio spectrum, a gap between the noise of the cosmos where communication could travel undisturbed. Morrison and Cocconi, the fathers of modern SETI, once wrote that any intelligent civilization capable of physics would know the hydrogen line and would use it as the universal meeting ground. If we are to receive a message, Cocconi said, it will come through hydrogen. And now it had. The signal from 3I Atlas did not drift. It did not wobble with Doppler shift or scatter from interference. It sat exactly at the center of the hydrogen frequency, as if anchored by intention. No known natural source behaves with such stability. Even pulsars, the precision clocks of the universe, show minute deviations as they spin. This signal was unwavering. perfect to the thousandth decimal. The universe is never perfect unless something wills it to be. The periodicity added another layer of wonder. Every 142 seconds, the signal pulsed in a steady rhythm, echoing its own frequency in temporal form. At first, some thought it a coincidence, a poetic alignment of numbers. But the repetition was exact, neither accelerated nor delayed by the object's movement through space. Natural oscillations drift with temperature, with orbit, with spin. This one did not. It was as if the pulse followed a clock outside of physics, a deliberate sequence detached from any mechanical rotation. Teams across the globe compared their data. From Australia to Chile, from South Africa to Spain, every receiver measured the same signal strength, the same frequency, the same interval. If it were a random fluctuation, each instrument would have recorded it differently, distorted by atmosphere and location. But the hydrogen line signal from 3I Atlas was universal, the same everywhere, as though it were meant to be shared equally by every observer on Earth. At the SETI Institute, one researcher stood staring at the display, silent for nearly a minute before whispering, "It's broadcasting from the center of everything." Those words captured what everyone felt but could not express. Hydrogen is not just an element. It is the first word of creation, the foundation of all matter. To speak through hydrogen is to speak through the language of existence itself. The question, however, was how. If 3I Atlas was truly emitting a signal, it would require technology capable of isolating and sustaining the hydrogen line with extraordinary precision. To generate a carrier frequency at 1420.4058 MHz requires not only intention but design. The possibility of an artificial mechanism became impossible to ignore. Could a comet-sized body produce such a signal naturally? Could the emission be caused by magnetic interactions or by resonance within its metallic compounds? Simulations failed to replicate the pattern. The spectral purity was too high, the timing too controlled. In an emergency session of the International Astronomical Union, scientists debated the results through the night. Every attempt to classify the phenomenon as natural collapsed under scrutiny. If it is a comet, one physicist remarked, it is a comet that understands mathematics. The line was meant as humor, but no one laughed. The periodicity of 142 seconds fascinated mathematicians. The number corresponded roughly to 1/10 of the golden ratio squared, the same constant that defines the Fibonacci sequence previously found in the modulation of the signal. This coincidence linked the two discoveries, the mathematical code and the hydrogen carrier, into one coherent system. The pulse was not just a random emission, it was structured thought. The sequence, the ratio, the frequency, all parts of the same language. Richard Feynman once said, "What I cannot create, I do not understand." Perhaps that sentiment applied here in reverse. Humanity could not yet create a signal of such purity over interstellar distances, and therefore did not yet understand what intelligence might be capable of doing. The data grew clearer as the object neared the Sunday. Unlike the roar of a pulsar or the flicker of a quasar, the 1420 MHz signal remained steady, calm, and intentional. It seemed less like an explosion of energy and more like a whisper in a cathedral, balanced perfectly between silence and presence. Some speculated that the signal was a navigational beacon, a method of maintaining position within gravitational fields. Others suggested it might be a communication protocol, a mathematical handshake waiting for a response. A young researcher in Australia proposed a haunting idea. Perhaps the signal was not meant for us. Perhaps it was a call, a synchronization tone designed for something else to hear. That thought lingered in the air, heavy with both awe and dread. If the hydrogen line is the universal meeting ground, then humanity had just wandered into a conversation that might have begun long before its existence. The absence of natural correlation made the evidence even more unsettling. The frequency did not vary with the object's rotation or orbital shift, as it should have if the emission came from the surface. It was as if the source of the signal was detached from the physical body, operating independently, perhaps inside it, perhaps beyond it. Carl Sagan's words returned to mind. Somewhere, something incredible is waiting to be known. In this moment, that something had arrived not as a message written in symbols, but as a vibration carved into the most fundamental constant of the cosmos. By now, the global scientific community could not deny the implications. The hydrogen line had always been humanity's chosen frequency for listening. Now it was being used from the other side. It was as though someone had reached across the dark and touched the same universal key. Freeman Dyson once remarked, "The measure of intelligence is the ability to make things that last." If this was indeed an artifact of intelligence, then its endurance across light years proved that wisdom might outlive even the civilizations that create it. The signal had crossed distances that human imagination can barely contain, carried on the wavelength of hydrogen, speaking to anyone who had ever looked up and wondered. As 3I, Atlas, continued its silent path behind the sun, the pulse persisted calm, rhythmic, flawless. It was not a shout, not a cry for attention, but a quiet assertion of existence. The universe had always spoken in the language of energy. Now, for the first time, it spoke in the language of understanding. The signal kept pulsing, as if the universe was breathing through numbers. Each rhythm followed the pattern of life itself, repetition, harmony, decay. But when 3I, Atlas, reached its closest point to the sun, something began to change. The pulse grew softer, slower, until it disappeared beneath the solar glare. For a moment, humanity stood still, listening to the silence between stars. The message had stopped, or perhaps it had only moved beyond what we could hear. The silence was coming,